is, so we looked at these two food chains, right? So let's see how they compare and contrast. Are they points of comparison, contrast? So there are some structural and some significant differences between the two. The first is that this is very structural, so very superficial, right? In the industrial food chain, the equivalent of the decomposer in biological is called a recycler. The decomposer is bacteria. Here it's a recycling plant, whether it's a paper or steel or plastic. And that's a very superficial difference. The second is there's an additional actor. We have a disassembler, right? Because you got an automobile, right? You got to strip it down before it can go to a recycler. But in the natural world, there is no disassembler. All of the disassembling is done by the shark when it feeds on a large fish. It unfortunately disassembles the fish, and so there is no separate disassembler. And again, this is not a significant difference between the two. It is very structural or superficial. Now, one of the most significant differences between the two, and one that this course is all about, is that there is little by way of resources lost in biological systems, but there's a lot that is lost in an industrial system. Natural systems are inherently recycling in nature, conserving in nature. Even the waste of one becomes the input to the other. So that's one significant difference. Now, other key differences are in terms of speed in adapting to change. Suppose there is a trade war, or there is rival competition. Walmart has Target competing. Walmart can quickly react, or Target can quickly react, and pick the phone, call suppliers in the US, outside of the US, and get the problem solved by the end of the day. In a biological system, if you have disruption or there's competition, that's not that easily solved. I mean, if it is two different prides of lion, it's settled in ways that in which human beings cannot. So there is speed of change, and then response to increased need for resources. In the industrial world, this could be that increased consumer demand. So Walmart can get to its supply chain and get additional supplies sent by the end of the week. If in a biological system, because there were more, the reproduction rate was high, and there's a lot of little lion cubs or tiger cubs to be fed, there is no calling somebody on the phone and ordering extra zebra meat. So the response is different between the two. And the third is approach to initiative, right? Biological systems are typically reactive. Industrial systems tend to be proactive. Walmart is, as we speak, watching this trade war between the United States and the European Union, and with China and elsewhere. And so Walmart's upper management is planning on what if, and you can bet they have plan B, C, D, and E. Walmart is not going to say, we run out of school lunch boxes because China is not sending them to us. But lions and tigers have no way of knowing these things. They just stumble upon a drought, they just stumble upon famine, and they just react. So industrial systems are proactive, biological systems are reactive. So there are similarities and points of comparison, but to bring this line of discussion to a closure, the most important takeaway is we want to be able to emulate the recycling nature of biological systems in industrial organisms. We want to keep waste down to as low as possible. Currently, industry generates lots of waste. So we can learn and see if there is something we can apply from biological systems which seem to produce less waste, or even if they have waste, those wastes can become input for the next trophic level. I'll give you an example. You say, well, doesn't make any sense. Well, it does. Consider the process of iron and steel making. In this process, a material called slag is produced. Slag is basically some combination of limestone and ore material. You run a blast furnace or a Bessemer furnace to make steel and iron, not to produce slag, but slag unfortunately is produced. So what do we do? Well, it turns out slag can be used as a material in road making. Likewise, you have this problem of mounds of rubber tires that we use for our vehicles. What do you do? Well, now they're able to grind that up and use it in an asphalt mix. So, waste from one can become an input for another. You see, we never used to do this kind of stuff 20, 30 years ago. Waste was just waste. We begin to think about this, but more needs to be done.